Hi, and welcome to Linear Functions tutorial number 2. So last class, we worked with the graph of a line. We saw that a line could be either increasing or decreasing. We knew that to find whether it was increasing or decreasing, we could read it from left to right like we read a book, because everybody in the world reads graphs from left to right. Or we could choose to sign our name on the line, and if our name was going up, the line has a positive slope, and if our name was going down, it has a negative slope. We also talked about finding the rate of change. Slope, those two words are interchangeable, and we talked about finding two corner points, and then starting with the lowest corner point, and finding your rise by counting up, and then running over to meet your second point, which of course would be called your run. And so the rate of change, of course, refers to how much rise there is to the run. So that was last class. And so now we're going to talk about that linear functions can be expressed as a graph, as we've seen, or they can be expressed as an equation or a table. So right now we're going to look at the equation y equals 3x minus 2. And you're going to have to trust me on this, that this equation actually represents the same linear function as this graph does. So now we're going to focus on equations of lines. And so when we look at an equation of a line like y equals 4x plus 10, it actually tells us some things. This equation, y equals 4x plus 10, is actually in slope-intercept form. We'll learn about that in a little bit. But what it shows us is it gives us the rate of change. We don't even have to do rise over run. All we have to do is look at the number that's right in front of the x, and that is our rate of change. So for this equation, the rate of change is 4. Now, since 4 is positive, we know that the rate of change is increasing. So we're going to circle that. So that's what we're going to do today. We're going to be looking at equations of lines. So go ahead and write this equation down. I know it's not on your sheet, so write y equals 7x minus 2. We're going to look at equations of lines. Just identify the number in front of the x and say, wow, that's great. When it's in this form, the slope-intercept form, the number in front of the x automatically is the rate of change of the slope. 7's positive, so that means it's increasing. All right, let's keep doing this. I'm going to have to actually put that down. So write this next equation, y equals negative 5x plus 8. Once again, we're going to look at the number in front of the x. That is our slope. So our rate of change is negative 5. Since there's a negative, negative 5 is negative, that means it's decreasing. It's a rate of change that is decreasing. The next one, please write down y equals 1/2 x plus 7. And once again, we are going to look at the number in front of the x. We see that it's a fraction, 1 over 2. So the rate of change is 1 over 2, which we know means that this linear equation rises up 1 before it runs over 2. So the graph would be up 1 over 2, up 1 over 2. Now some people get confused because a half is a fraction and it is smaller than 1, but it's still increasing because it's positive. So this one is increasing. All right, on your next sheet, go ahead and write down y equals x plus 3. And you'll notice that we always have been squaring, or not squaring, but putting a box around the number in front of the x. And we're like, oh no, there's no number. What do we do? So when there's no number in front of something, we have to ask ourselves, well, how many x's are there? Because over here, right, when we saw the 4, we're like, oh, there's 4 x's, 7 x's. So here, there's nothing, but we do see 1 x, right? So when x stands alone, it's another way of saying that there's just 1 x. Kind of makes sense, right? If I'm going to give you an apple, I'm like, here's an apple. I'm not going to say, here's 1 apple. So same thing whenever we see x and it's just by itself. We're going to see it as x, but it will help us if we go ahead and put the 1 in its place so that we have something to put a box around. So the slope, the rate of change is 1. 1 is increasing because it's positive. All right, so go ahead and write this next one down, y equals 8. And we're like, oh no, there's no x. There's literally no x. So we can stop and we can rewrite this in a way that can help us. When there's no x, we can write that. There are 0 x's, and then we can put plus 8. Okay? When we do that and we put a box around the number in front of the x, we see that the rate of change is 0. Now, this is a tricky one, right? Because you don't see a negative, so you're like, is it positive? 0 is tricky in that way. It's neither positive nor negative. It's just kind of a neutral number. And so it's not increasing, it's not decreasing, it's neither. And when we get more practice with graphing, we'll understand why y equals 8 has a rate of change of 0 or slope of 0. And this last one, go ahead and write down y equals negative x plus 9. Once again, if I were to just pick up my blue pen and put a box around what's in front of x, all I would see would be a negative. I'm like, oh, where's the number? When you see an x, whether there's a negative or not, and you don't see a number, you know that number is 1. Negative x is the same thing as negative 1. And if I put a box around what's in front of x, that gives me my rate of change, negative 1. And since negative 1 is negative, that means it's decreasing. So what's our takeaway from this page that we just did? When the equation of a line is in this form, y equals mx plus b, which we'll learn more about later, we know that we can just scoop out that rate of change by looking at whatever number is in front of x. And then we can tell if it's increasing or decreasing by whether there's a positive or a no sign in front of it, because, right, like when I see a 4, there's no plus in front of it, but we know 4 is positive, or negative, and we actually see a negative.